So guys, what we have discussed till now, uh, we have discussed about the two methods, O of 1 and O of n. And in O of 1, we saw that as number of input increases, the time more or less remains constant. And in O of n, we saw as the number of input increases, proportionally the time also increases. So we said that O1 is a better than O of n. But guys, do you notice one thing, that I have used O of 1 and O of n? O of 1 for the constant time and O of n for the proportionally increasing time. But do you have a question that why I have not used t in place of O? Because basically it's a time. So I should have written t of 1 and t of n. T of 1 to define constant time, and t of n to define linearly increasing time with number of inputs. So this is because discussing this, I want to ask you a question, that does all the machines are same? So answer is no, because all the machines are different. Some might have 6 GB RAM, some might have 8 GB RAM, some might have 4 GB RAM, and in some machines high applications are already going on. In some might have already have some high applications currently running in the computer. So basically all these factors affect the time taken by the program. Okay, so it might be possible that a same code that is taking 10 to the power minus 5 second in one computer will take 10 to the power minus 4 second in another computer. So this is not a standard thing. Time changes with machine to machine. But to make it standardized for all the machines, basically instead of using time, we use operations, and O stands for operations, that is big O. It stands for operations. So what does O of 1 and O of n means? It is simply means that O of 1 means that the number of operations are constant. Okay, that is it is constant with the number of inputs. As number of input increases, number of operations are constant. So if we see in our previous lecture, we talked about smart method. So in smart method, you saw that there is only a single operation, that is we define total is equals to a simple formula, that is we assign the total variable some value, that is a formula we assign. So basically this assignment thing is a simple O1 operation. Okay, that is one operation. So we call that method as O1. And when we talked about the naive approach, where we applied the for loop, basically for loop runs as number of times as the input is there. So if the input is 6 times, number of inputs are 6, it will run 6 times. So each time when the for loop was running, we call is a one operation. So you can see that as the number of input increases, number of operations increases in that code. So this is the concept that we use O of 1 and O of n instead of T of 1, T of n. Okay, so guys, up to here I have defined only two techniques, that is O of 1 and O of n, but there are another technique also, and I will show you all the techniques in the graph. So please let's see the graph. So this is the graph. So first of all, I have already told you that why we are using big O instead of T, because we know that time is not constant for all the machines. It varies from machine to machine. So to standardize our codes, to standardize this time complexity, we use a number of operations that are there in the code. And in the and I've already shown you that whenever we assign a variable to something, or whenever we assign some formula to a variable, it is basically a simple O1 operation. But whenever there is a loop in the code, it will become O of n. Okay, time complexity of that code will become O of n. So guys, so these are all the different time complexities chart. So this y-axis, you can see that is the operation, that is just you can assume it is over time, and elements is the number of variables, how number of the inputs. So you can see that as the best technique is O of 1, that is in dark green color. After that, O of log n technique is there in light green color, and after that O of n is there in yellow color. So we have discussed only these O1 and On technique till now, but I want to give you the glimpse of some other technique like O of n log n, O of log n, O of n square. When will they arrive? When we will say that this code has this type of time complexity. So O of log n, when we are applying binary search, then it will be of O log n, and when we are using sorting algorithms, then the algorithms have time complexity of O of n log n. And whenever there is a nested loop like for loop inside the for loop, the time complexity of that code is of n square. So don't worry guys, we will discuss all these techniques one by one in our later lectures. I just want you to give the glimpse of these things. Okay, so these are all different techniques, and you can see that O1 is the best technique any code can have, and we generally operate in O of n, and we rarely go above O of n square. We will see some rare problems in O of n square. Okay, so first of all, I want to show you the goodness order, that is which one should we prefer first. Like first of all, we will try O of 1, then O of log n, then O of n, then O of n log n, O of n square. You can see this in the graph also. Okay, so the question is, can we apply O1 in all the cases? So answer is no, because as the complexity of the problem increases, it is not possible to solve the problem in O1 method, and mostly you will see that most problems are so much complicated that it will be solved by O1 only, O of n only. In the above example that I have already shown in my previous lectures, in the naive approach and the smart approach, you saw that in the question was simply to find the sum of first n natural numbers, and we were having a formula that is n plus 1 by 2. So we directly calculated it with O1 approach. But if think about that, the question is given that there are 100 random numbers and you don't know any formula and nothing. So what you will do, you will simply apply the for loop to calculate the sum of all the numbers, and that will take the time complexity to O of n. Okay guys, so if you have any doubt, that will be clear in further lecture. So we will meet in the next lecture. Thank you very much.